All right, today we're going to be talking about properties of rational exponents. So we're taking what you already know about this. We're going to make it a little bit more difficult. Going to put some fractions in there because I know everybody loves fractions. So let's go ahead and let's get started. Exponent properties. So this is what you're supposed to already have known. A to the m times a to the n. Here we would add the exponents. Add the exponents. A to the m all to the n. Here we would multiply exponents. Over here, AB all to the m, what you would do is you would distribute this m to both of those. So A to the m, B to the m. These are all things you're supposed to know already. A to the 0 is going to be 1. A to the negative m, going to bump it down here to the bottom, make it a positive exponent. Over here, when they are dividing, use the subtraction rule, so m minus n. And over here, a over b all to the m, again, since it's parentheses, you want to multiply those exponents. So a to the m over b to the m. These exponent properties are what you're going to use today and what you have been using already. The problems are going to get a little bit more difficult because of fractions, but you're using the exact same properties. So the only difference is the fractions. So let's go ahead and move on down here. Use the properties of rational exponents to simplify the expression. So again, we have parentheses. What do we do with the exponents? We multiply them. Now don't get all crazy because it is an exponent here. It's 1/2 times 4/5. So I'm just going to use my calculator. 1/2, 4/5, and I get 0.4. Well, we want to turn this into a fraction. So math, enter. So 2/5. So 3 to the 2/5. And you can go ahead and just leave it just like that as your answer. Over here, 1 over 27 to the negative 1/3. What do we do when we see negative exponents? We bump that up to the top and make it a positive exponent. So 27 to the 1/3. Now, you can do a little bit more with this if you want to. Let's think about 27. Let's break down 27. It would be 9 times 3. And that's 3 times 3 times 3, right? So couldn't we say that's 3 to the 3rd? And then let's bring down that 1/3 from up here. Okay, so we're bringing him on down, boom, like that. Okay, what's 3 times 1/3? Well, it's 1. So your answer is just a plain old 3. So only 27 to the 1/3. Over here we could work with this, but I'm telling you now it won't go any further than this, okay? I just wanted to show you that. Over here we got all kinds of things going on. So first things first, we have the same base here. If we have the same base, we can add our exponents. So in the calculator, we're going to do 1/3 plus 4/3. And some of you can do this part in your head, right? So math, enter, it's going to be 5/3. So 9 to the 5/3 over 3 to the 1/3. Now, you're thinking, ooh, I'm just going to do the subtraction rule and be all done. But you can't do that. We have a 9 here. We have a 3 here. Got to have the same base. Well, 9 is 3 to the what? 3 to the 2nd. So 3 to the 2nd all to the 5/3 over 3 to the 1/3. Let's go ahead and multiply these exponents together. So 3 to the 10/3 over 3 to the 1/3. Now you can do your subtraction rule. So we'll have 10/3, subtract off 1/3, just in case it's a fraction. Ooh, it wasn't, it's just a 3, right? So 3 to the 3rd, and when you do that in the calculator, you get 27. See, that ugly problem turned into a beautiful 27. Okay, let's keep going. And remember, at any time, if you want to pause it, write stuff down. If I'm going too fast, I am the type of learner where I would watch the whole video, and then the second time I would go through and write it down. So I would probably watch a video twice, but that's just how I do it. Okay, let's look at D. On D, we have this exponent here, so we're going to multiply it in. So 3 times negative 1/3 is negative 1. 3 times negative 1/3 is negative 1. Now you can't add those exponents though, because that's a 4 and that's a 2. But 4 we can write as 2 to the 2nd. Okay? And then once we do that, we have these two right here we can multiply together. Now you can add your exponents. So negative 2 plus negative 1 is negative 3. You better not leave that. It's a negative exponent, so it must go on to the bottom here. And then 2 to the 3rd is 8. So 1/8 is our answer. Let's go over to E. Ooh, it's not looking pretty at all. But you know what I'm seeing here? I'm seeing they both have a 1/2. So you know what? Instead of having them separate like this and breaking it up and doing all that stuff, let's do this. Let's see if this does anything for us. We can rewrite this problem as 52 over 13 to the 1/2. And then on the calculator, 52 divided by 13 is going to give us 4. Great. This looks way better already. So 4 to the 1/2, we can leave that, but what is 4? 4 is 2 to the 2nd. What's 2 times 1/2? 2 to the 1st. So just 2. And some of you can look at this and tell me, oh, that is the square root of 4, which is 2. And you can skip right to it. Whatever works for you, do it that way. Whatever works. All right, so that's simplifying those. Let's keep on going. Let's go to the next page here. So example 2, simplify. Okay, so, all right, what's going on here? Well, it's kind of hard to multiply this 8 in when I don't even have my fraction going on. So let's go ahead and flip these to fractions. So this would be 5 to the 1st, but it's the 4th root, times 5 to the 1st, but it's the 8th root, all to the 8th power. I'm just going to go ahead and distribute this in first. You can put these guys together if you want or distribute. It's totally up to you. All right, so 1/4 times 8, 5 to the 2nd, and 1/8 times 8, 5 to the 1st. Then we can add our exponents, 5 to the 3rd, and get 125. So the whole big mess turns out to be a nice, pretty number again. Let's look at B. Now, that is really ugly, and what I would probably do first is see if I can do it in the calculator. So I would hit 8 first, and then if you go to math, option number 5 is what I'm going to pick, because we're doing 8th root, and that's not on this list. So 5, and then do 1, 3, 1, 2, 2. Yeah, that's real nasty. It's not happening. So what are you going to have to do? Well, you're going to have to break it up with a little factor tree here. So 1, 3, 1, 2, 2 divided by 2. 6, 5, 6, 1. All right, 2, 6, 5, 6, 1. And I know it's not divided by 2. We can't divide it by 5. That's 11, 12, 18. Now, if you add all 4 of these digits together, you get 18. And since 18 is divisible by 3, so is 6, 5, 6, 1. That's a little trick. So add all the digits. If that number is divisible by 3, so are all the other ones. Look at that. 2, 1, 8, 7. So let's see if this one's divisible by 3. 2 plus 1 is 8. 8, what did I just say? 2 plus 1 is 3. How about that? 3 plus 8 is 11, and 11 plus 7 is 18. So 3 also goes into this one. There we go. So divided by 3. And we just keep going. 729, that's 9, that's 18. This one's also divisible by 3. It's a long one. 243, that's 6, 7, 8, 9, that's divisible by 3. 3 and 81. Now we're getting to some numbers that we can actually think about, right? So 9 and 9, 3 and 3. Okay, that's a lot of 3's, but we can handle it here. I'm just going to kind of bring everything down because I was one of those students in school that totally forgot to do that all the time. This is an 8th root. 8th root, 8th root, 8th root. You cannot take anything out unless there are 8 of them, okay? So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 3's. So we could take a 3 out, but this little 2 right here, you have to keep him inside. Just like with the square root, you need 2. With the cube root, you need 3. Well, with an 8th root, you need 8. Okay? So that is B. So let's look at C. I know 32 over 243 will not simplify. So I know I magically knew that. So I can't do anything with that. So the next thing you got to do then is basically, let's just work this out. First thing, can we take the 5th root of 32. Let's see if it works out. Oh my gosh, it does. All right, so this is 2. Can we do the 5th root of 243? See, I always check it with the calculator if I'm not sure. Let's do 243. Oh yeah, how about that? So I guess if you do the top in the calculator, do the bottom of the calculator, you get 2/3. That's a smart way of doing it. So always check with your calculator first. All right, let's move on down to D. Okay, that's looking like something we did when we had square roots. We can handle this. They both have cube roots. So I call these guys outies. Okay, they're the coefficients here of the cube root. So 4 times 6, 24. And then we're going to have cube root of 25 times 5. Well, if you don't know that one off the top of your head, you can always do it in the calculator and you get 125. And then you want to do the cube root of 125. Now, what did I say? Try it. with your calculator first, and let's just see if it comes out pretty. Look at that. Beautiful. It's a 5. So we have 24 times 5, and then 24 times 5 is 120. Ta-da! There you go. So 120. All right, let's look at E. That looks crazy. So we can't take the square root of any of those things. None of them are perfect squares. We could put the top together, 32 times 6. You know what? They all have the same radical, so you could also divide this into that. So, okay, so let's do this. What's 32 times 6? Because they're both innies and they have the same root. So 192. So we have square root 192 over square root of 3. Now, couldn't we write this as one big square root? Couldn't we say this is square root of 192 over 3? Now, if we do that, let's see if anything happens. 64, how about that? Okay, so we have square root 64. And you should know what the square root of 64 is. Boom, right off the top of your head. So answer is going to be 8. Let's look at F. Fifth root of 125, square root of 5. Do you notice? That's a fifth root and square root. Okay, so don't just go, oh, I'll do 125, I'll divide it by 5, and then I'll take the whatever root of it. No, you can't do that, okay? You gotta take care of each thing individually. So you could write, and here's what I'm thinking. So I can write 125 as 1/5, and I can write 5 as 1/2. Now, I can't do the subtraction rule, though, because they don't have the same base, but couldn't I take my 125 and bust it up? And if I bust it up, I get 5 to the third. It's 5 times 5 times 5 if you do the little factor tree. Now, if I have that, I have this, the 1/5 on the outside, and then I have my 5 to the 1/2 on the bottom. And then 3 times 1/5, so 5 to the 3/5 over 5 to the 1/2. Now I can do my subtraction rule because now they have the same base, which is 5. So we have 3/5 minus 1/2, and we have 1/10. So we have 5 to the 1/10. Now, just because they gave it to me as a radical, I'm going to actually give it back that way. So to write that as a radical would be the 10th root of 5 to the 1st. If you want to leave the 1 there, you can. If you want to take the 1 off, you'll look a lot smarter. So I'll let you decide what you'd like to do there. But that's how I'm going to leave it. And I'm going to take the 1 off because I want to be smarter. So there we go. All right. So remember, you can pause this. You can re-watch it. You can watch it through the first time and then go back and write the notes a second time. You know, if I'm going too fast, there's no reason to say I'm going too fast because you can control everything. This is totally under your control. So down here, perform the indicated operation. We're going to talk about these in class. So in class, we will handle these two problems. So see you then, and I'm glad that you watched the video. You're wonderful. Until next time.